In this video, I'm going to use the formal epsilon delta definition of a limit to prove that the limit of a linear function, here's my function f of x equals negative 2x plus 1. I'm going to use the formal definition of the limit to prove that the limit of that function as I approach 3 is actually negative 5. So let's remember how the epsilon delta definition works. So it's as if I've claimed that this is true, and there's some heckler out there who doesn't believe me. So they're saying, oh yeah? You're saying that your y values get close to negative 5. I bet you can't make them that close. So their challenge comes in the form of a distance, and they're challenging me to show that I can force the y values of my function to be within that distance of negative 5. And I need to be able to shoot down their challenge. Okay? And I need to be able to meet that challenge no matter what the challenge is. Okay? So for any positive number, which would sort of establish a standard of closeness for how close they're challenging me to make the y values to negative 5, for any such standard of closeness, I can find a positive number, delta. I'm going to use that to establish a standard of closeness for my x values. So that if I control my x values, and this is a two-part inequality here, the first part just says that the distance between x and 3 is bigger than 0. That's going to mean that x isn't 3. Now for this particular problem, we don't care if x is 3 or not because nothing weird happens at 3. But that's an important part of the definition because sometimes a function might have a hole or some sort of unexpected behavior at the point where we're evaluating the limit. This just says we're not looking at what happens there. This part of the inequality says we are looking at what happens close to 3. So the distance between x and 3 is going to be smaller than this number delta, which I'm going to find. And if I control my x values in this way, then my y values are going to do exactly what I said they were going to do. The distance between my y value and negative 5 will be smaller than epsilon, smaller than this number that I've been challenged with. Okay. Now, in using the definition in order to do a proof, there's basically going to be a two-step process. I'm going to go through some informal work to find this number delta, and then I'm going to write up the formal proof to prove that the delta that I found actually works. Okay. The reason that I need to do some informal work first is that I have no idea what delta is. I just have this goal in mind. So I'm going to start in my informal work. I'm going to start with this inequality that f of x minus negative 5 is less than epsilon. Now I can't do that in a formal proof because that's the conclusion that I'm trying to get to, and I can't start with my conclusion. In my informal work, I'm just sort of exploring, well, what else would be true if my conclusion is true, to see if that'll help me figure out my delta. Okay, so let's see. F of x, that was just negative 2x plus 1. Subtracting, sorry, I had two negative signs there initially. That should have just been minus a negative 5. Those two negative signs become plus 5. I want that to be less than epsilon. So I'll add the 1 and the 5, so I get negative 2x plus 6. Less than epsilon. And then I'm going to factor out that negative 2 that's in front of the x. And when I do that, still inside the absolute value, I get negative 2 times x minus 3. And I want this to be less than epsilon. Now, absolute values distribute over multiplication. So, rather than multiplying and then taking the absolute value, I can take the absolute value of each piece and then multiply them. And that's what I want to be less than epsilon. But I know that the absolute value of negative 2 is just 2. So I want 2 times the absolute value of x minus 3 to be smaller than epsilon. Now notice here, I did not factor out a negative 2. I factored out the absolute value of negative 2, which is a positive 2. That's very important. Because as I look here, I see, oh, there's the absolute value of x minus 3. That's the distance between x and 3. That's the thing I'm supposed to be controlling with this number delta. So if I take this inequality and I just divide both sides by 2, I'm going to get that the absolute value of x minus 3 is less than epsilon over 2, and I'm pretty sure that that's the number delta that I was looking for. So now I'm ready to write up my formal proof. I've found a delta that I think works. The formal proof will just show that that delta does what I need it to do. So for my formal proof, it's always going to start with the same basic pattern. First line, let epsilon be bigger than 0. Acknowledge that there's a challenge, because we're going to prove our claim by saying, hey, if anybody challenges me, I can defeat that challenge. And how am I going to answer their challenge? With this number delta. So the second line is to introduce my delta, and that's my epsilon over 2. So now I'm trying to prove an if-then, and I always do that by supposing that the if part is true. Remember, that's like performing a thought experiment and then saying, what happens if we do make that true? So I'm going to suppose that 0 is less than the absolute value of x minus 3 is less than delta. Now, as I mentioned, for this particular problem, this part of the inequality that tells me that x isn't 3 isn't really needed. What I need is this part of the inequality, which tells me that x is close to 3. So I'm just going to sort of spell that out. I'm going to say that the absolute value of x minus 3 is less than epsilon over 2, just substituting in the value of delta that I had found. Okay. And I know I'm going to need this later, so I'm just going to put a little star by it so that I can refer to it later. Okay. Now, I'm trying to show that this inequality is true. So I'm going to switch gears, and I'm going to introduce this thing that I'm trying to show is smaller than epsilon. Nice transition word is the word consider. That just says, okay, I'm done, introducing things and supposing things. Now let's move on and talk about what I really want to talk about, which is the absolute value of f of x minus negative 5. Okay. All right, so the absolute value of f of x minus negative 5 is, I'm just going to substitute in the formula for f of x, that's negative 2x plus 1, and then minus a negative 5 is a plus 5. And that's equal to the absolute value of negative 2x plus 6, just doing that arithmetic. Now, it feels like I'm doing a lot of the same stuff that I did over here, and I am, but here's the difference. I can justify every one of the equalities and eventually inequalities that I'm writing in my formal proof. Over here, this inequality sign wasn't justified. I had no reason to know that this was true yet. So all of my work was based on this inequality that I hadn't justified yet. Here, I'm just working with an expression, not two sides of an inequality. I'm working with that expression, and I'm taking small steps to simplify that expression and say things about it that I know are true. And the next thing that I'm going to do is going to be to factor out that negative 2. And then I can come up here and I can use the fact that the absolute value distributes. So this is equal to the absolute value of negative 2 times the absolute value of x minus 3, which is equal to 2 times the absolute value of x minus 3. Excellent. Now, I know something about this because I have supposed over here by star that this thing is less than epsilon over 2. So if I have 2 of this thing, then I know that that's going to be less than 2 of epsilon over 2. And that is justified by the supposition that I made earlier on. All of these other steps were justified by the fact that I was just doing arithmetic or substituting in a formula, very obvious reasons why they were true. This is true because we supposed it earlier in the proof, but that's equal to epsilon. So what we just did is we started with the absolute value of our function minus the number that we claimed was the limit. through this chain of equalities and then ultimately a less than, an inequality, we showed that that quantity was less than epsilon, which is exactly what we needed to show. Probably a good idea to acknowledge that that was what we were trying to get to. So I'm going to say, thus, the limit as x goes to 3 of f of x is equal to -5. I always like to just state my conclusion because this is complicated enough that if I just stop, not everybody's going to realize that I stopped because I was actually done with the task that I was trying to do.